So hello everyone, and in this lecture we're going to learn about trajectory equation and finding the trajectory equation for a particle. So let's begin with what trajectory is. So trajectory is nothing but the path followed by a point object during its motion. It's nothing but it's the path followed by a point object during its motion. This is the definition of trajectory. So you would have seen like some jet planes flying, right? Sorry for the bad run again. Well, this doesn't look like a plane. Sorry for that. Okay, so you would have seen jet planes flying in the sky, leaving a white trail behind, right? A white smoke behind. So as the plane goes ahead, it leaves on this white trail behind. So if you look at this trail, as the plane goes forward, if you look at this trail, this traces the path that is traveled by this plane, right? Trail. All right. So this traces the path which is traveled by the plane. So, and that's what we call as trajectory. It's as simple as that. All right. So you understood what trajectory is. Trajectory is nothing but the path followed by a point object during its motion. That's it. That's what trajectory is. So now we'll look at what trajectory equation is. So when it comes to equation, we need to understand what in which coordinates we're going to write the equation. So we use Cartesian coordinates. The first, or we may even use polar coordinates. Mostly we use Cartesian coordinates in this case. So we'll look at the equations. So what is a trajectory equation? So writing a trajectory in mathematical form, or writing a trajectory mathematically, is what trajectory equation is. So we need to establish a definite relation between the x coordinates and the y coordinates of the particle which is transversing in the plane. In this case, if this is a 2D plane, let's say 2D. So we set our plane in such a way that the plane contains the particle and it has a definite relation between its y coordinate and x coordinate. All right. And this definite relation is what we call as a function, a mathematical function. A mathematical function. Such as you have, let's say, y is equals to sine x. So one minute. Suppose these are the x and y axis and the particle is going in such a way, in a sinusoid way. Follow the sinusoidal function. All right. So this is the trajectory of the particle. All right. So this is the trajectory of the particle, and we see the x coordinate is related to y coordinate as y is equals to sine x, and this is the trajectory equation. And this is how we actually write the trajectory equation. So basically we write it as, in general form, is y is equals to f of x. So y is a function of x. This is a trajectory equation, general trajectory equation. So relating x and y and writing it in the equation form is what trajectory equation is. And now let us understand how can we find the trajectory equation. So as I said before, by establishing a definite relationship between x and y coordinates, we can get the trajectory equation. All right, so this is how it is, and we'll do it with the question now. We'll start with the question. Let's see what the question says. So we'll write a question over here. So the question says, a particle moves in xy plane according to the scheme x is equals to minus 8 sine pi t and y is equals to minus 2 cos square 2 pi t, where t corresponds to the time. So find the equation of the path of the particle. What we have to find is trajectory, or more correctly, equation of trajectory of this particle is supposed to be found out, which is missing. So we could see that the x coordinates and the y coordinates are related with time over here. So what if I eliminate this variable t over here? Then I'll get a good relationship between x and y. So that's what I am gonna do right now. So what I can write is minus x by 8 as equals to sine pi t. You have sine square pi t is equals to x square by 64. Say this is equation 1. And you have cos square of 2 pi t is equals to minus y by 2. Then you can write cos square of 2 pi t as 1 minus 2 sine square pi t, which is equals to minus y by 2, and there's no harm in doing this. And in this, what we'll do is we'll take this minus n and 2 over there. So we want to basically write this as y is equals to f of x as mentioned earlier, right? So you got y is equals to minus 2 times 1 minus 2 sine square of pi t. So from equation 1 we have is y is equals to 4, and in sine square pi t I'll write x square by 64 minus 2. So I get the relation as y is equals to x square by how much? 16 minus 2. And that's what the relation is between y and x coordinates. So this is the trajectory equation of the particle. I hope the question is clear to you. So if we look at it carefully, this is a parabola. So we'll try to construct it. So how do we do it? Let's draw the axis. So you see that the equation is okay. Wait, this is the y-axis, this is the x-axis. Y is equals to x square over 16 minus 2. So when x is equals to 0, you'll have y is equals to minus 2. Minus 2. And when y is equals to 0, you will have x square as 32. So you'll have x is equals to root of 32 plus minus. So this is 4 root 2 minus 4 root 2 and plus 4 root 2. So these are the roots of the equation. The minus 4 root 2 and plus 4 root 2 are the roots. And then the parabola should go like this, if I'm not wrong. So this is a rough sketch. This is not the exact sketch, but then that's how the trajectory is. And this is how we finish our question. All right, I hope it's clear. So we'll end our lecture here. Thank you so much.